Hello, in this video I will be talking about the first problem in the formulation tutorial. But before that, I want to talk a little bit about getting started with formulation and give you a few tips on how to approach a formulation problem. First of all, it is challenging. Formulation is challenging, but it's not actually that difficult to be good at. There aren't any magic recipes that will make you suddenly good at it, but you do get better with practice, and I will be making sure that you get a lot of practice. You really shouldn't be repeating the problems we go through over and over. Let's not memorize the solutions, we just need to pick up on the patterns. No two problems are exactly the same, of course, but if we can identify the type of the problem, that will be a lot of help. So, what are we supposed to do when we have to formulate a problem? What do we even begin with? Well, first of all, we need to read the problem and put ourselves in the shoes of the decision maker. Then we need to ask ourselves three questions. What is my objective? And what is keeping me from reaching this objective? And finally, what is the thing I can manipulate or change in order to achieve this objective? Okay, I will now start with our problem. I'm going to read it, then I will try to answer the aforementioned questions, and I will explain why I'm asking them. Okay, the Denver advertising agency, promoting the new Bream dishwashing detergent, wants to get the best exposure possible for the product within the 100,000 advertising budget ceiling placed on it. To do so, the agency needs to decide how much of the budget to spend on each of its two most effective media. 1. Television spots during the afternoon hours, and 2. Large ads in the city's Sunday newspaper. Each television spot costs $3,000, and each Sunday newspaper ad costs $1,250. The expected exposure based on the industry ratings is 35,000 viewers for each TV commercial and 20,000 readers for each newspaper advertisement. The agency director knows from experience that it is important to use both media in order to reach the broadest spectrum of potential Bream customers. She decides that at least 5 but no more than 25 television spots should be ordered, and that at least 10 newspaper ads should be contracted. How many times should each of the two media be used to obtain the maximum exposure while staying within the budget? Okay, we are now the decision makers at the Denver advertising agency. So what is my objective? What is the thing I aspire to achieve? It is actually quite explicitly mentioned here that we want the maximum exposure for our product. This is actually going to help a lot with the objective function. Second question is, what is stopping me from reaching my objective? I would be very happy if my product gets a limited exposure, but alas, there are many factors that keep me from getting my wish. First of all, I have a limited budget of $100,000. This restriction will actually be translated into a numerical constraint later. And now to the third question. What can I control or change to achieve my objective of exposure? Well, we have two channels of exposure, TV spots and newspaper ads, and we have the power to decide how much of each to pay for, and that's how we get our decision variables, which is awesome. This means that we almost made it. We have some extra restriction here on the number of spots and ads. We can get we have to get at least 5, but no more than 25 TV spots, and at least 10 newspaper ads. We should keep that in mind for later, since it's going to also be translated into constraints. Okay, at this point we've done 50% of the work. We just need to translate everything we just talked about into a mathematical model. The first step is actually defining our decision variables. We said that we can control how many times we use each exposure channel. So our decision variables, labeled here x1 and x2, represent consecutively the number of TV spots to order and the number of ads to contract. Next, we will be defining our objective function. We've already stated that our objective is to maximize the total exposure we get from all the TV spots and newspaper ads we'll be paying for. And as we can see here, exposure is measured in the number of viewers or readers. Hence, the total exposure will be expressed by summing the number of views generated from all the TV ads we will order and the number of readers from all the newspaper ads we contracted. So this is how our objective function looks like. And now we will be moving to the constraints. We obviously have the budget constraint. The total cost of TV spots and newspaper ads should be less than or equal to our $100,000 budget, and we get this total cost by multiplying x1, which is the number of spots we will decide to pay for, by the cost of one spot, and we add the cost per one newspaper ad multiplied by the number of ads we will be contracting. This entity should be less than or equal to $100,000. I guess that's very clear. We also have other constraints that were very explicitly stated in the problem. We need to have at least 5 but no more than 25 television spots. So this translates to x1 greater or equal than 5 and x1 less or equal than 25. Same thing for the number of newspaper ads. It says that at least 10 newspaper ads should be contracted. So x2 is greater than or equal to 10. And last but not least, we have the integrality constraints. x1 and x2 should be positive integers. Of course, we can't have 0.25 ads or 0.5 spots. So the number of spots or number of ads should be integers, and they also should be positive. We can't have -1 spot or ad. Thank you very much for your attention, and I hope this was clear. Let me know if you have any questions.